oxide, it's not zinc oxide. How do we know that? How are we going to be choosing here? So it's actually confusing many students. So I have a solution here. So most students will be saying, fuck, I'm photoreca species because they're so confusing, but it's actually easy. So what we're going to be doing here is like in this one. So anyways, what we're going to be doing is, first we're going to look at the compound. We're going to look at it. Second, look if there is a hydrogen ion. And third, look if it has a vacant site so that it accepts proton, because in amphoteric species they act as both an acid and a base, so which basically makes them to accept a hydrogen ion or hydronium ion, and also they're going to be donating a hydronium ion or hydrogen ion. So basically what we're going to be doing is look at the structure, or we're going to be drawing the Lewis structure. So basically, in an easy way, you can just draw it like this, but this is not the right Lewis structure. I just draw them because it's actually going to be easier to look at it here, but you need to go through the Lewis structure steps and like form the correct structure. Basically, it's actually the correct structure is like this. But for now I'm going to use the easy one just to make you understand for better. So if we're going to be like drawing it like this one, like there's HCO3, right? Just count the valence electron. If you count the valence electrons, there are total 24 electrons. So which makes them that to form a hydrogen ion in this bond, to make a hydrogen bond, is either needs one electron gain or to lose that hydrogen ion. Because if you look at it, there's an 8 here, and also an 8 here. So which is going to be 24. So if it means 24, how is this supposed to make a hydrogen ion? So to form this bond, we need an electron. So to find electron, we're going to be gaining an electron. So which means that first when we look at the compound, second we found a hydrogen ion, which is this one, a hydrogen. So the third one is look if they have a vacant site. Yes, it's going to be having a vacant site. To accept it, we're going to be accepting one electron and then going to be forming a hydrogen ion here. So if the accept is going to be stable, right? So we are supposed to make this structure possible, which is the correct one is basically this one. So if we looked at this one, to make this a hydrogen bond, we need an electron. So that's why. So it satisfies both cases. So that's how amphoteric species work. So